Hi, it's Graeme Cox here, co-founder of OptiSurface, and we've recently done some analysis on a centre pivot field in northern Queensland, and this video will discuss our findings. So the study is called Atherton Tablelands Centre Pivot Field Drainage and Runoff Analysis. This is the field. That was the scope of works. So the survey, the topography was captured by BMS, and they conducted some soil sampling as well. The topography is collected with RTK GPS. It's legend's a bit hard to see there, but we've got basically, oh, that's quite a bit of fall. Each one of these contours is 420 millimeters of fall. So 4 meters of fall over that distance. So yeah, quite steep here. Quite steep in some of these areas. Ignore the elevations outside the pivot. They were only added to allow the runoff analysis to calculate within the pivot with more stability. Here's an NDVI map of that same field, and looks like this is probably without any crop in it, but there is some drainage issues happening here. Not sure what's happening here. Maybe due with the maturity of the crop, I think they spread their planting patterns out. Another NDVI map. I don't know if there's probably some crop in here. There's something happening here. We can see that's the steeper part of the field. So we're probably seeing some either runoff or erosion problems maybe showing up in those parts of the field. Here's another map with another NDVI map from that date there. Again, there's some issues here. Potentially there's runoff occurring maybe around the pivot tracks, maybe concentrating and running down here possibly, causing problems. So that could be erosion problems. There's that drainage problem's not too bad here. Okay, here's a U map of the pivot. Not really useful, doesn't really show up much at all. Okay, and the report it details how the drainage analysis and the runoff analysis is carried out. These are the inputs to the runoff analysis with the local 1 in 10 year rainfall intensities and the furrow geometry that was given to us. The results for north-south running furrows, the surface drainage is quite good, except there's a couple of small spots here. There's a ridge here that stops the water furrows from draining at the end here. Same here. The runoff analysis, the arrows, these little arrows here actually show the runoff velocity, and at 0.7 meters per second it goes from blue to yellow. We like to try and keep the runoff velocity below about half a meter per second. Here it's signifying the yellow is starting to get a bit risky at 0.7. We did increase the legend a bit, but we'll try to keep it a bit lower than that. The surface shading in the background is actually the runoff depth. Brown with the lowest depth up to purple here. So you can see the water's building up depth and velocity as it flows this direction. The catchment area increases, and this is where it starts to get high velocity because of the slope and the upstream catchment area in each furrow. So that's quite a high risk erosion area there. If we overlay the runoff arrows on top of the existing topography, we can see that more closely. So you can see there it's quite steep here. That's where you get the high velocities. There's a little bit there, a little bit there. These are just the runoff velocities by themselves overlaid on the satellite image. So you can see high risk erosion areas here. Now if you did put a road across the field here and drained this water off to one way, you need a grassed waterway on that road, I think, to carry the water safely. But you could potentially solve this erosion problem here. We didn't look into that, but that is another option, possibly. Here's the analysis, the same analysis if we run the furrows east-west. You see we've still got the drainage analysis still shows there's ponding problems would exist here. If you cut a drain through the furrows or the beds of the crop, then that would drain out, and that's possibly what they've done. Here's a runoff analysis in the east-west direction, and it's not too bad, except here it starts to build up velocity. It's the same with the arrows over the existing topography and over the satellite image. So it's better than running it north-south in terms of the erosion risk. There's less area that's orange and red and yellow probably. So that's probably a better option. So then what we did was optimize the furrow direction to try and limit the erosion risk. So we tried many different furrow angles and came up with a 70-degree direction, which is there, 70 degrees to north. And you can see that it doesn't really create any ponding problems more than is already there. By the way, you can solve this ponding problem by doing some minor earthworks here to get this field to drain out, possibly a little bit of earthworks here. Here's the runoff arrows and runoff depth map. You can see it's much better. It's more easily seen probably on this map here. You see there's only one area that gets up above 0.7 of a meter per second, so much better. Ignore these arrows outside the pivot. They are based on assumed elevations outside the pivot and don't really have are not really there. So that's basically the results we did. We were also asked to provide some analysis or some feedback or comments on the potential placement of sediment traps, and the comment there would be that this is the lowest edge of the field. There's a natural watercourse going through here, and the erosion risks appears to be, if they continue to run farm north-south, appears to be here and some here. So draining that water around to some type of sediment, a sump here, sediment trap here, would be logical. Maybe you could put another one here to catch this here, and another one here, a secondary one. That's our thoughts on that. And if the furrow direction was switched around to this 70 degrees, then it's probably possibly wise still to have some type of sediment trap, and again down in the lower part of the field, as water's going to drain around here. You'd need a drain around the edge of the field to take it down to a sediment trap before it runs into the watercourse. We're also asked to provide some comments on the pivot irrigation application rates based on topography, slope, soil types. So it is a red volcanic soil that probably has a reasonable infiltration rate. The pivot's not too large. I think it's like that's 100 meters there, so it'd be about 350 meters diameter, so it's not too large. The slopes are quite high in areas which could cause runoff problems during irrigation. Rotating to 70 degrees row direction could help that. Okay, that's basically it. Thanks for watching, and I'll look forward to any feedback.